Hello there. In this video, we talk about the zeros of polynomial functions. But first of all, we need to talk about what a polynomial function is. So what are polynomial functions? In the previous video, we talked about what a polynomial is, right? So a polynomial function then of degree n is a function that looks like represented below. The only difference between this and what we talked about previously is that this is a function. So you have a left side and the right side. It says p of x equals an expression as shown here. As with polynomials, polynomial functions are described in terms of certain parts of them. The degree, for example. So this example here, this generic example, is a polynomial function of degree n, and degree has the same meaning as we described previously as far as a polynomial is concerned. So the degree of this polynomial is n. It has a leading term, a sub n times x to the power n. The leading coefficient is the coefficient of the leading term, a sub n, and the constant term is a sub 0. For example, f of x is 2x minus 3. Y equals negative x cubed plus x squared minus 5. P of x equals to 7. These are all examples of polynomial functions. And let's characterize them a little bit more. For this first one, 2x minus 3, you can see that the degree is 1. The highest exponent is 1. The leading coefficient is 2. And the constant term is negative 3. For the second polynomial here, it's a polynomial of degree 3. That's the highest exponent. The leading coefficient is negative 1. The constant term is negative 5. And for this third one, p of x equals to 7. This one is a constant function. It's p of x equals to 7. It's only made up of a constant. Equals to 7. It's a polynomial of degree 0. And the reason is because the highest exponent is 0. You can write 7 as 7x to the power 0, right? That's the highest exponent. That's why it has a degree of 0. The leading coefficient is 7. The constant term is 7. And p of x is an example of a constant function, right? P of x equals to 7. Now, whenever you have a function, you can always evaluate that function for its value at specific points of x. So, for instance, in this, whenever you have a polynomial function, you can find out what is the value of this polynomial when x has a specific value. For instance, if you have a polynomial f of x that's equal to 2x minus 3, you can find f of negative 1, or f of 7, or f of k. So what is f of negative 1? Well, that means let x be negative 1 in your function for every x value in there. So f of negative 1 will be 2 times negative 1 minus 3. 2 times negative 1 is negative 2, so you have negative 2 minus 3, your result is negative 5. So therefore, f of negative 1 is negative 5. What about f of 7? We can do the same thing. That means we let x be 7 for every value of x, or for every where x is indicated in the function. So f of 7 will be 2 times 7 minus 3, that's 14 minus 3, that's equal to 11. Therefore, f of 7 is 11. What if you are looking for the value at k, at any point k? K is some real number, f of k. Well, you can do the same thing. We let every x be k in the function, so f of k is 2 times k minus 3, which is equal to 2k minus 3. Now that we know what a polynomial function is, we can talk about the zero of a polynomial function. So whenever you have a polynomial function p of x, that polynomial has a zero at r, where little r is a member of the real number, if p of r is equal to 0. That is, when you evaluate p of x at a point r and the value you obtain is 0, then you say little r is a 0 of p of x. That's the meaning of what I've written down here. Okay, so p of r is 0, r is called a 0 of p of x. Now, whenever you have a polynomial p of x there is always this related equation p of x equals to 0. That is when, when y is 0, what is the solution to that? That solution is the same thing as the 0 of the polynomial. So if r is a 0 of a polynomial, then r is also called the root of the related equation p of x equals to 0. And don't worry, we will make this really clear with examples. So for example, is negative 2 a 0 of this polynomial p of x equals to x squared minus 5x plus 6? To find out if negative 2 is a 0, we evaluate the function at negative 2. That means, what is p of negative 2? P of negative 2 is negative 2 squared minus 5 times negative 2 plus 6, which if you simplify, you will get 20. P of negative 2 is 20. Because p of negative 2 is 20, that means that negative 2 is not a 0 of the polynomial. Because for negative 2 to be a 0, p of negative 2 has to be equal to 0. So since p of negative 2 is not 0, negative 2 is not a 0 of p of x. What if x is 3 in this same polynomial? Is 3 a 0 of this polynomial? Well, we can find out. What is p of 3? P of 3 is 3 squared minus 5 times 3 plus 6, which is 9 minus 15 plus 6, which is equal to 0. Since p of 3 is 0, therefore 3 is a 0 of the polynomial p of x. And from what we discussed previously, x equals 3 is also a root of the related equation x squared minus 5x plus 6. So if you solve that equation, 3 is a solution to that as well. It's one of the solutions. It's not the only one. Okay. So to find the zeros of a polynomial function p of x, we just solve the equation p of x equals to 0. So whenever you have a polynomial function given to you and you want to find the 0 of the polynomial function, all you have to do is solve the equation p of x equals to 0. So for example, let's find the zeros of this polynomial f of x equals to x squared plus 5x minus 24. That means we want to solve this equation x squared plus 5x minus 24 is equal to 0. This is a quadratic equation. You would have learned that there are several ways you can solve this equation, one of which is by factoring. We can factor this equation and we will obtain x plus 8 times x minus 3 equals to 0, which means that you are multiplying two factors together and you get 0. That means either one factor or the other is 0, and then you can solve those linear factors. Your result will be negative 8 or 3. That means negative 8 and 3 are the zeros of the polynomial function f of x equals to x squared plus 5x minus 24. Look at another example. Find the zeros of f of x equals to x squared plus 2x plus 1. That means we want to solve the related equation x squared plus 2x plus 1 equals to 0. Again, we can factor this. We get x plus 1 times x plus 1 equals to 0, which means really x plus 1 times x plus 1 is x plus 1 all squared. And if you solve this equation further, you will obtain that x equals to negative 1 twice. So this 0 is repeated twice. Okay. So when the 0 is repeated in that way, you say it has a multiplicity of 2. Right? The 0, negative 1 has a multiplicity of 2 because it is repeated twice. So that word multiplicity means it's the number of times the 0 is repeated. What about this one? Find the zeros of f of x equals to negative x plus 4 squared times x minus 1 cubed times 2x minus 1. Now, whenever you are solving, you are trying to find the zeros of a polynomial, like in the previous two examples, one of the things we did was that to solve it, you have to factor the polynomial. But the nice thing is this polynomial has been factored for you, so that solving the related equation becomes a little bit easy. You are just, you take the equation, the function, and you set it equal to 0. Since the left side is already factored, that means that each factor you can set to 0. Negative x plus 4 squared is 0. Or x minus 1 cubed is 0, or 2x minus 1 is 0. And if we solve each of those equations, for the first one there, you will find that x equals to negative 4 twice. For the second one, x equals to 3 times. And for the last one, x equals to 1/2. This means that for the first solution, or first 0, x equals to -4, it is repeated twice. That means it has a multiplicity of 2. X equals to 3 is repeated 3 times. That means it has a multiplicity of 3. And x equals to 1/2 has a multiplicity of 1 because that 0 is repeated 1 time. So these are the zeros of this polynomial function that we have here. So why don't you try this now by yourself? Find the zeros of this polynomial function. What I would like you to do is that you should pause this video now while you try to solve or find the zeros of this polynomial function. And when you have finished, you can continue the video to see what I have done. So please go ahead and pause the video now. So what did you do? Well, here's what I did. To find the zeros of the polynomial function, all you need to do is take the polynomial and set it equal to 0. And in this case, like in the examples we did, you have to factor the equation, the left side. So that means x cubed minus 4x squared minus 45x equals 0. If you factor that, you will get x times x squared minus 4x minus 45 equals 0. And one of the factors is quadratic, which you can factor further. So you have x times x minus 9 times x plus 5 equals to 0. And we can make each one equal to 0. X equals to 0, or x minus 9 is 0, or x plus 5 is 0, which will give you that x is 0, or x equals 9, or x equals to -5. So we have come to the end of our video on how to find the zeros of a polynomial function and what polynomial functions are.